So how do I register pass as a static plugin? So as I remember that this is a static plugin, so which means that you have to include the requisite information in the GCC source, and you will have to recompile the GCC source because you want to involve static linking. So declare your pass in this file freepass op.h. So for example, you could say extern struct gimpal of pass your pass name. Okay. Then add pass to appropriate pass list using the macro next pass. When Winnie was showing cscope yesterday, she showed you the list of passes. There was this macro called next pass. Okay, and we went and looked into one pass. Yeah, any question? Yeah. Okay. So add your file details to makefile.in. You have written the pass. Now you have to add details, configure and build GCC. Okay, if you want to simply test your pass initially, make sure that it's all right. Go to 3-stage building later. You can build CC1 only. Note that this freepass.h is a file that's included in every pass, everywhere. It gets included everywhere, which means that whole thing has to be recompiled. And of course, you have to debug CC1 using DDD or GDB. Note that GCC and CC1 are different executables. GDB helps you so there are different processes. GDB helps you debug a particular process, but it's possible for us to go to a sub process, child process using GDB. There are ways of doing it. You can see this message. So one of the common mistakes that we did when we didn't know anything was we would set up GDB on GCC, and whole GCC will execute, will set breakpoint on our function, but that breakpoint will never be reached because it was a different process. So these are things that we learned the hard way. So that was about static plugin. Yeah.
So when I register my plugin as static plugin, then there is some problem. There is segmentation violation. So how could I remove the plugin from the compiler while I'm changing the compiler?
The simplest thing that you could do is, because you have included in next pass this thing, comment out that.
No, but there's no way to do it from the command line. Specify, or I have to define the parameter for my.
Yes,
plugin.
you can define an option. You can define a command line option, and don't give that command line option, in which case that pass may not be used.
Like minus S plugin, there is no way for support from the compiler.
Of course, even if you give a command line option, if a certain pass list is executed and your pass is in that list, then it will get executed anyway. So you can't, strictly speaking, you can't do it without recompiling the program, because you're doing static linking. Now you want to undo the effect of static linking, right? So you need to do that.
Sir?
Yeah.
So regarding the same question, why can't we just change the gate function?
But you have to recompile the program.
Okay.
When you change the gate function, you have to recompile it.
No, so first time while I'm coding the pass, I'll write a gate function saying minus no pass means do not execute this pass.
That is possible. You can give an option. Yeah. So yeah, that's one solution. It's a good point. It's a good observation. So he says, I made a statement. So the reason so what statement did I make? I made a statement that if your pass is included in the pass list, then that will get executed anyway, right? So his suggestion is that if you give a command line option when not to execute a pass rather than when to execute a pass, and put it in the gate function, then even if it's there in the pass list, it will not be executed, right? I mean, I was thinking more about a command line option that says when to execute a pass. But yes, you can get the opposite effect by inverting that flag. Yes, that's a good suggestion. Interesting point. Any other question about static plugin? Then we'll go to dynamic plugin. Dynamic plugin issues are almost similar. Again, the pass structure is all same, except that it happens at runtime. And there's a small little thing that lets us do that. Okay. Remember, in the afternoon you have to do all this. You have to populate these structures and you have to do all these exercises. So, dynamic plugin. So supported on platforms with -LDL or dynamic, loaded using DL open, and this is a command line option. You have to specify plugin -f plugin path to LTO. We have specified a makefile that will help you do this. Incidentally, that brings me to a remark, an important remark. In order to ensure that in the small time that you are here, you get to do some useful things, we have tried to provide exact commands, etc. in the assignment specification. So you can simply cut and paste and execute the command. So the job will be done at that time. But once you go back, it would be worthwhile to understand the details of the command, worthwhile to look at the arguments, the options of the command, etc. Right now, you, in order to do something quickly, you can kind of take it as a black box, but later please open it up. It will increase your understanding. So here also, for the time being, you can simply say that this is thing, not worry about it, or you can simply use the makefile that we have given to you. It will be worthwhile to look at the details of the makefile, understand later. Okay, so let's look at dynamic plugin. I gave you the main idea, which is essentially an idea that comes from a first level programming course. You have a linked list, you have a function that adds a node to the list, you have a function that removes a node to the list. Now this may be done, so when we say add a node to a linked list, that happens at runtime. When we specify a next pass, the linked list is decided at compile time. We have the choice of deciding the linked list at compile time or at runtime. So assume that we have this pass list which has been created, and I have already compiled it. Now I don't want to disturb it. I don't want to change this pointer and recompile the whole source. If I specify it as a static plugin, I will have to use next pass and this whole thing will have to be recompiled. But I don't want to do it. I have written my own pass data structure in a separate file, and I have compiled this file separately. All that I want is somehow this structure has to come in this list, and that's where my first programming experience helps. First year course of programming helps. All that I need is something that sets up pointers like this at runtime. A dynamic plugin mechanism in GCC is just this. Okay, so this runtime initialization and made possible by dynamic linking, and so this is, let's say, our opt pass that we have specified. Okay, pass plugin, some simple IPA pass is a name that will be used for the purpose of printing a dump file. This is my execute function. Everything else is null. I really don't care. I don't want a sub pass. I really don't want a gate as well. When gate is null, there is no function. Pass is executed by default. So this is how I can specify my pass. Okay. Now I register this pass into pass info. So I say this is address of the new pass. So why is this pass plugin dot pass? Observe that this simple IPA pass is a structure inside a structure. Okay, we had basically an opt pass which is couched inside a simple IPA pass. Okay, recall this here. We just go back. We can see here simple IPA opt pass has this structure struct opt pass. Okay, and the name of the simple IPA opt pass variable is pass plugin. Okay, so now I pick up. So this is the pass field of that pass plugin. So address of this is actually ampersand pass plugin dot pass. So that's what gives me the name of the pass variable, the actual pass variable. And I specify name of the reference pass. This is a string. So this is such a string like this. This will be used. So I specify PTA. So please include it, and then I can say insert it after or before. Okay. And then I have to ensure a register callback. In this data structure, I essentially specify address of this data structure. This is pass info. This is the information of my dynamic plugin. So I have, let me repeat, I have specified my pass in the usual way. I have provided the location, etc. in this pass info structure, and now I have to register this pass info structure to ensure a callback, and I pass its address and pass info, where pass info is essentially this structure. So I specify this pointer and I am done. That is all that is required for the dynamic plugin. Once I do this, I can essentially get this effect. This is the original pass list, and a dynamic plugin, I end up getting this. Okay. So I guess that is the main thing. Then this make file has been provided, will be provided to you. So let's not get into too many details of what this does. But basically, it creates a shared object file of the pass. Okay, and then it invokes GCC with this particular -f plugin option. Okay, so this is the summary of what we would like to call as a plugin mechanism in GCC. Before I move further, I would like to take any questions. Yeah.
Is there any difference really between static or dynamic in terms of what you can do with it? There are some features that you can use in a static path that you can have in a dynamic or vice versa.
I don't think there is any difference. I don't think. Pratik, did you try your LIPTA pass as a dynamic plugin? Did you get time? Okay. She's going to try. She's defined a dynamic static pass, and we want to give it to you for use on day after tomorrow. So I suggested to her that we should convert it to a dynamic plugin so that you don't have to recompile. So I don't think. Would anyone, Swati, Prashant, would anyone like to comment on it? Is there something that?
There is a related question. GCC getting address of this structure is okay. You can do DL open and ask for DL attack. How will the pass access global variables of parent process? It's not a process, the same process. How will the plugin get to know about global variables in the
So that is the essentially.
Because that will answer your question. There will be more globals sitting in the CC1, which the plugin will get to access.
So GCC has to export all of those.
No, assume all are
exported. That's a global data, and this is a code. So your code has to be aware. This part of the code has to be aware of that global data.
So I declare them as what external, or I get their addresses by name. Then I have to make so many calls to get all the addresses from the parent.
No, it's a global variable. So simply use a global variable here. So dynamic linking is supposed. So dynamic linking is supposed to take it.
Declared as external in
Yes.
the plugin. But can I make such a?
They're declared as externals in plugin.
So you declare them as externals and compile, and it will be a .so file having so many hanging externals.
In fact, in every pass we do declare them as externals.
I see.
In every pass, we just took it as a default, so I didn't realize the significance of it.
Actually, this is not clear from documentation that you can declare externals and
No,
they will be bound to corresponding names, because names are not supposed to be known at runtime. If CC1 happens to be a script executable, it doesn't have any name.
So I don't know how dynamic linking. Maybe that's where the dynamic, R dynamic, etc. comes into play.
As far as I know, CC1 exports also can know, and it's not stripped by the rules.
Pardon?
So it's not stripped.
So at runtime you cannot be knowing names of those variables, right?
No, maybe we should.
So how will a plugin access?
No, Dhananjay.
Yeah.
Maybe we should just try NM on CC1.
Yeah, that will answer. Yeah, we'll do that.
Because if
on the
and the other thing
the
that
problem is with SO.
the other experiment that we can do is we can look at run NM on this thing, get all the names, and then we strip it. Let's strip CC1 and then use dynamic plugin. Let's see whether it works. Then your question will be answered.
But script one doesn't contain any name.
Yeah, exactly. So it should not work. I don't expect it to work.
Okay.
Maybe the dynamic linking will fail.
We'll try.
In fact, I would assume that dynamic linking would require global data. How would linking happen otherwise?
No, you ask. That is actually one problem with DLSIM function. You have to know name of the function to be able to get the address.
Yes. So dynamic linking, I think, presupposes.
So on the SO side, it is okay. You keep the name available. What about the CC1?
Exactly. So
If
dynamic linking.
keeping all the names
So if you
available,
want, it has to. I would like to conjecture that, I would like to hypothesize that dynamic linking presupposes availability of all
one is
the
compiled with names availability.
Yes.
And
Otherwise,
will
conceptually, I
merge
think
the externs with corresponding.
I think so, because conceptually I can't visualize what will happen. How will a dynamic linking work if you don't know the global data here, the external data here? Linking means external data, accessing external data.
So that will make your pointer analysis work. Because you don't know after you load a SO.
Yes, in fact that's a good point.
You don't know who will anchor onto the same global.
That's a good point. I mean, not only are plugins bad, if static plugins are bad, dynamic plugins are worse.
Yes.
For the kind of analysis that I wish to do. Yes, dynamic plugins are. Yeah. The more you think, the more you keep things delayed. Yeah.
So I don't see like the advantage of static plugins. Why are they good?
As in?
Static plugins seems to be a more modular approach than static plugins. Why
Yes.
is static plugin not good?
Because dynamic plugin came later. I mean, I really have no other answer to that later. I really don't have any other answer.
Dynamic plugin, you can say it's for private use. Yeah, if you think you are doing something for the whole world, you distribute it as part of GCC, everyone gets it. Or if I am solving my problem with some plugin, okay, it's my private plugin, use at home only.
No, I mean, his argument is perhaps you can make GCC execute faster if you distributed it as a collection of dynamic plugins. But then I don't know how many options will you give on the command. How many .sos will you open? If I want 200 passes to be executed on my... So, yeah, I mean, that will be terrible.
The advantage is you may not recompile the CC.
That is the advantage, but the counterpoint is that if I want to execute 100 passes one after the other, do I specify minus FL open or whatever it is for all those 100 passes? I don't know. Dynamic plugin is good to include one pass. Yeah, Kristu?
I think it is for the development. For example, if you want to add a new path, so at the time of the development stage, you may need to recompile it more time. So 10 or 20 times.
That
so
is,
once you fix that, okay, you can add it as static code, whatever it is.
yes, that is indeed the case as far as software engineering practice is concerned. The other motivation is, as Dhananjay was saying, that maybe it's my private path. I don't want to give it out to the rest of the world. But I think this discussion brings us to an interesting observation. The static plugin is meaningful for things that you want to execute anyway. Dynamic plugin is useful for some small things that you may want to execute in some instances but not in others. So dynamic plugin is not a part of default plan of the compiler. Let me see.
Says that okay, I will include all the plugins for all the languages that I support. And at the runtime, based on the extension, I will choose whatever plugin I want to use for the password. I mean, why do I need to specify?
Because CC1 is language specific. Plugins come in CC1. Language independence comes in GCC. GCC is the driver. So, if you want to compile C++ with GCC, it will call CC1 plus. For compiling C, it will call CC1. So we are still within. So this the picture that we see in the structure is still same, but they are different executables. So languages are not mixed in the same executable. Yeah.
If I want to make a pass to execute multiple times,
Yes.
say like dead code elimination, for example. If I want this to be called multiple times after so many passes, then how do I approach here?
Current technology simply says that you call it multiple by specifying it using next pass.
But if I don't find any change in the code after some times, I would like the path to be taken as different.
So you can write a gate function to observe that. You can write a gate function which checks whether there's something for it. Yeah.
And one more advantage of using the dynamic thing is like
you don't want to bump up your executable size of CC1.
You don't want to
increase the size of your CC1. You can load it to the runtime.
I don't know what you mean by increasing that. I mean, are you worried about disk space or are you worried about memory?
Executable size.
Disk space, I don't think these days anybody works about disk space.
One of that.
It's the dynamic memory that one is worried about, but then you are anyway increasing the size of the dynamic memory that you can't get away.
There you can load it and unload it if you want.
I don't know how to unload it. If you have an answer, please come to me. We really have been struggling with this. I need dynamic unloading. Unfortunately, I don't know how to do it. I'll be very happy to figure out a way of doing dynamic unloading. I know how to. I mean, we are looking at different contexts, but we are struggling with the same thing. And when we talk about link time optimization, I will describe to you what we have done, why we are unhappy with what GCC has done, and what we would like to be seen done. But I don't know how it can be done. Is there a way of doing dynamic unloading?
No, actually Unix says clearly dynamic unloading should not be done because once you unload ISO, one particular ISO, and load another, there is a possibility that next ISO which is on the same virtual level, where the function pointers are all same address.
Of course, this is
Because think of it as overlay in Windows.
I think it is. Amit, is Amit there? Amit, is this the reason why our dynamic unloading did not work? Of course, the context is different, but in a sense, we also have, when we read from .o files, we also have a space that represents the memory. Could this be the reason why it did not work? Yeah. So, did you get his answer? His answer is that you have a certain .so and you bring in some other .so, but other pieces of code would have the function pointer to the same thing. Okay, and that will create a problem. So, which means that in order to bring in, in order to unload something and bring in something, we have to redo the whole data structures, particularly when we have function pointers. So, is it that our expectations are unreasonable? I think that's a good point. We should talk about it. Maybe we didn't realize that our expectations.
One more question on that. What does DL close exactly do? Is not clear to me. Like DL open, there is a DL close. What does it do? It closes the DLL, but what happens to the addresses which was held by DL open? That's not clear to me.
No, he is talking about the dynamic loading. I was
using DL open, DL sim, I am getting pointer to the plugin. Correct? If I do DL close, has the plugin vanished?
No. What Amit looked at was a different context. So this is slightly different. When we talk about link time optimization, I'll describe the problem. But maybe the difficulty that we faced can be explained by the remark that you made. Maybe. Yeah. I want to execute pass n minus 1.
So I did say
I gave the notion of subpass.
No, but I want to execute the previous pass in the pass.
This is not a doubly linked. This is singly linked.
So if I insert a pass after some optimization, and I want to call optimization passes again, can I do that?
They will sum that can be pointed back to some previous pass.
I mean, you have to know the name. He's saying, I don't know the name.
No, I know the name.
If you know the name, then you specify it as a subpass.
So that will create a cycle.
Yes, that will create a cycle.
But then we use the base function to build that cycle.
I mean, you can say, count the number of times it has been executed and then say, I'm tired now. I don't hope. Yeah. If you can have controlled recursion using this, that can be done. I thought that you said, I don't know the name, but whatever was the previous pass, please redo it. That is hard because it's not a doubly linked list.
But you can always walk through the chain and
Yes,
figure out who is
that's
who.
the other option. So because you have pass variables, in the execute pass list, you invoke that pass variable once again. So this all passes will get executed once
But
again.
generally that's bad programming, right? You have pointer into something which you don't know. We'll ask him to leave or something.
It's ready. So I think we will stop here.